June 25, 2024. Inner Mongolia. A capsule the size of a washing machine slams into the desert at dawn. Inside, 1,900 grams of gray powder that's about to shatter everything we thought we knew. Not about some distant exoplanet. Not about a galaxy far away. About the object that's been hovering over humanity for our entire existence. See, we've been staring at the moon for thousands of years. We've written poems about it, sent 12 people to walk on it, mapped every crater, every mountain, every ancient lava flow. But we've only ever seen one side. The other hemisphere, the far side, has been radio silent, untouched, a 14 million square mile blind spot in our cosmic backyard. What came back in that capsule is the first soil ever retrieved from that hidden world. And it's telling a story that doesn't make sense. Volcanoes that erupted when the moon should have been frozen. Chemistry that rewrites the moon's birth. Natural nanotechnology forged in microsecond infernos. Everything we thought was settled? It's not. Let's open the capsule. There's something profoundly strange about our moon. It shows us the same face, night after night, year after year. The dark patches of ancient seas, the bright highlands of impact craters, the rabbit, the face, whatever pattern your culture sees in those shadows. But turn it around. Look at the hemisphere that's been hidden from human eyes for all of history. And you're staring at an alien world. No dark seas, no smooth plains. Just endless, violent craters stacked upon craters upon craters. It's as if two completely different moons were stitched together along an invisible seam. Scientists call it the far side. The public calls it the dark side. Though that's a misnomer. It gets just as much sunlight as the side we see. What makes it dark is our ignorance, our complete lack of access. See, there's a problem with exploring the lunar far side, a rather significant one. When you're on the far side of the moon, Earth disappears below the horizon. No line of sight, no communication, no way to control a rover or receive data from a lander. It's radio silence, complete cosmic isolation. Every lunar mission before Chang'e 6 had to play it safe, landing on the near side where Earth was visible, where communication was possible. The far side remained this tantalizing question mark, hovering 240,000 miles away. The Americans studied it from orbit during Apollo. The Soviets photographed it in grainy black and white. But nobody had touched that soil. Until China said, "What if we don't land there alone?" The solution was audacious in its simplicity. If you can't communicate with Earth from the far side, then put a relay satellite in a position where it can see both Earth and the far side simultaneously. Thread the needle. Bridge the gap. That's exactly what China did. In 2019, they placed a satellite called Queqiao at a gravitational sweet spot beyond the moon, a halo orbit, around the second Lagrange point. From there, it could see what we couldn't. 5 years later, Chang'e 6 launched. On June 1, 2024, it touched down in the oldest, most heavily cratered region of the lunar surface, the South Pole Aitken Basin. Not just old, ancient. A scar nearly 1,600 miles wide, blasted into existence when the moon was still young, when the solar system was a shooting gallery of violent collisions. This wasn't just a landing. It was an archaeological dig into the moon's earliest memories. The lander scooped up 1.9 kilograms of soil and rock, fragments of a world we'd never touched. Then it launched that precious cargo back to Earth, where it parachuted into the deserts of Inner Mongolia on June 25th. Inside those 1,900 grams were answers to questions we'd been asking for half a century, and some answers we didn't expect. Here's what we thought we knew. The Moon is geologically dead, a cold, inert rock that exhausted its internal heat billions of years ago. The near side has those dark volcanic plains, the Maria, because lava flooded them early in the Moon's history, roughly 3 to 4 billion years ago. But the far side? Almost no volcanic features. Too cold. Too quickly. Case closed. Then the samples arrived. Among the fragments brought back by Chang'e 6, scientists found volcanic rock. Not ancient, 4 billion-year-old basalt, but stones dating to 2.8 billion years ago, some possibly even younger. Wait, back up. Volcanic activity on the far side. 1 billion years after the Moon was supposed to have frozen solid? This shouldn't exist. The Moon doesn't have plate tectonics. No recycling of crust. No subduction zones pumping magma to the surface. By conventional models, its heat engine should have sputtered out long before this rock formed. And yet, here it is. Physical proof, sitting in a laboratory, that the lunar far side was erupting lava while Earth's continents were just beginning to stabilize, while life on our planet was still single-celled and learning to breathe oxygen. Something kept the far side warm. Some internal furnace we don't understand. Maybe radioactive elements clustered in unexpected pockets. Maybe tidal friction with Earth played a longer game than we realized. Maybe there's a heat source we haven't even considered. What's clear is this: the Moon wasn't dead. It was holding on, volcanic, active, alive in ways we never imagined. And that raises a disturbing question: what else were we wrong about? The samples revealed something else, something unexpected in the chemistry. They're dry, not just low in water, profoundly depleted in volatile elements. The lightweight molecules that should be baked into the lunar surface. Hydrogen, carbon, nitrogen. The building blocks that could have been delivered by comets and asteroids over billions of years. On the near side, we find these elements embedded in the soil, signatures of ancient cosmic deliveries. But the far side samples? Almost nothing. It's like opening a time capsule that's been sitting in the desert versus one that's been sitting in a rainforest. Same planet, radically different conditions. This matters because it speaks to how the Moon formed. The leading theory says the Moon was born from catastrophe. A Mars-sized object called Theia slammed into the infant Earth 4.5 billion years ago, ejecting an enormous cloud of vaporized rock that coalesced into our lunar companion. A cosmic collision so violent it melted everything, leaving behind a molten shell that cooled into the Moon. If that's true, the Moon should be relatively uniform. The near side and far side should tell the same story. But they don't. The far side is drier, older in appearance, more scarred, less volcanic. It's as if the two hemispheres had different childhoods. Some scientists now wonder, what if the Moon's formation wasn't as simple as we thought? What if the two hemispheres formed under different conditions or merged from separate debris clouds? What if Theia's impact left an uneven legacy? A lopsided Moon with a split personality. The dry soil from the far side is a clue, a piece of evidence in a cosmic mystery that stretches back to the birth of our world. Now here's where it gets really interesting. The far side isn't just different, it's undisturbed. While the near side's surface has been partially resurfaced by lava flows, the far side has remained frozen in time. Layer upon layer of meteorite impacts, stacked like pages in a history book. No volcanism to erase the record. No geological activity to shuffle the deck. What that means is this: The soil on the far side contains meteorite dust that's been accumulating since the earliest days of the solar system. Dust from asteroids that smashed into the moon 4 billion years ago. Fragments from comets that visited when Earth was still a hellscape of molten rock. This is primordial material, unchanged, uncontaminated. And here's the wild part. That same rain of debris that hit the moon also hit Earth. But on Earth, plate tectonics, erosion, and life itself have erased almost all evidence of that ancient bombardment. Our planet is a palimpsest, constantly rewriting its own surface. The moon has no such amnesia. Every impact is preserved. Every meteorite leaves a fingerprint. By studying the far side samples, scientists can reconstruct what was flying around the early solar system, and by extension, what was hitting Earth. They can trace the chemical signatures of asteroids from the outer solar system, the icy visitors from beyond Neptune, the volatiles that may have seeded Earth's oceans and atmosphere. The far side isn't just a museum of the moon. It's an archive of Earth's forgotten past. And we've only just cracked open the first page. But perhaps the most bizarre discovery is still to come. Hidden among the lunar dust, scientists found something that shouldn't exist in nature: single-walled carbon nanotubes. Let's pause on that. Carbon nanotubes are cylindrical molecules made of pure carbon, rolled into tubes just 1 atom thick. They're stronger than steel, conduct electricity better than copper, and are usually synthesized in high-tech laboratories under carefully controlled conditions. They don't just form naturally, especially not on the moon. And yet, there they are, embedded in the far side soil like microscopic needles in a haystack. How? The answer appears to lie in the violence of impacts themselves. When a micrometeorite, a grain of cosmic dust smaller than a pinhead, slams into the moon at tens of thousands of miles per hour, it doesn't just hit, it explodes. The collision creates temperatures exceeding 3,000 degrees Celsius in a fraction of a second, a miniature star, blooming and dying in an instant. In that flash of heat and pressure, carbon atoms are ripped apart and reassembled. Graphite gets vaporized and reforged, and under just the right conditions, the atoms snap together into these perfect hexagonal tubes. It's natural nanotechnology, forged by chaos. What's staggering is that this process has been happening for billions of years, every time the moon gets sandblasted by cosmic debris. The lunar surface isn't just a passive target. It's an active chemical workshop, building complex molecular structures through sheer brute force. And we never knew, because we were only looking at one side. So here we are, a mission that lasted 53 days, a capsule that carried less than 2 kilograms of soil, and yet it's forcing us to reconsider everything. The moon isn't a dead rock. It's a world with volcanic secrets, chemical mysteries, and a hidden history that stretches back to the birth of the solar system. For 50 years, we thought we understood our closest neighbor. Turns out, we were only seeing half the picture. And now that we've finally glimpsed the other side, the real questions are just beginning. What else is hidden in that ancient dust? What other impossible molecules are waiting to be discovered? And what will the next mission bring back? Because this is only the first sample from the far side. There's an entire hemisphere out there we've barely touched, and it's been waiting 4.5 billion years to tell its story. Thanks for watching. If this made you rethink what you thought you knew about the moon, hit that subscribe button. We're covering the discoveries that change everything. What should we explore next? Drop your suggestions in the comments. Until next time, keep looking up, even at things you think you've already seen.